Good. On to this webinar today from the Open Group, which I think is the third in 2016. Today we're talking about microservices architecture. You can see we've got a fantastic panel with us today. I'll hand over to Chris Harding of the Open Group, who's chaired today's event. I'd just like to go over a few housekeeping issues to keep the event moving forward smoothly. With regards to questions, and of course, I'd encourage you to ask questions. If you ask a question to the panel, then do is to write your question into the text QA facility. Do write a question in there. Can I ask you to address it to all participants? That way, I get to see all questions that are being submitted. Our plan today is to try and answer as many questions as possible at the end of today's presentation. If you'd like to simply share a comment with a fellow attendee, then the best way to do that is via the text chat facility. Now, the event is being fully recorded, so if for any reason you have to leave early or experience any local technical difficulties, and I know sometimes audio can be a problem around the globe, then everyone who's registered for today's event will get an email with the appropriate link where they can access the full recording. That should come out tomorrow. So if you're ready, can I ask you to start us off?
Very much, Simon, and welcome everybody to this webinar on microservices architecture. This is the third in our series SOA in the digital age. We've talked about developments in SOA and SOA for business, and we're on to the interesting and very hot topic of microservices architecture. Microservices evolved partly as a reaction to the perceived complexity of enterprise SOA, but it's taken life and perhaps of its own in some respects. So we have we will be looking at questions like whether microservices are an evolution of SOA and how they should be used in enterprise architecture. And we have a distinguished panel to address this. Peter Maloney is a senior engineering fellow at Raytheon Company. He's had a long career path, became interested in enterprise architectures and SOA as a result of the need for providing access to increasingly complex data products, and he is a Raytheon Certified Architect, a program accredited by the Open Group, and a 3-time winner of the Raytheon Excellence in Technology Award. He holds a patent and has authored more than a dozen papers. Bell has been a user of SOA since its early days, with significant experience of establishing a service-oriented enterprise architecture and deploying SOA solutions within a major corporation. He's now also involved in standards activity as chair of the IEEE SOA and Web Services Working Group, and he's also a co-chair of the Open Group project to maintain alignment between the Open Group, the IEEE, and ISO on SOA reference architectures. John, in fact, will be give initial presentation with additions by the other panelists to prepare us for the discussion period. Is a TOGAF 9 certified enterprise architecture practitioner and has a wealth of experience in consulting engagements and SOA, not only in his former company, but he's now with Salesforce.com, which is giving another dimension to his consultancy, his experience. Ovis Loon is an engineer and an enterprise architect and practice principal at Hewlett-Packard Enterprise. He has a significant work experience in areas that have a strong bearing on microservices architecture, including developing embedded systems, smart grid design and implementation, SOA, and integration and Internet of Things, cloud computing, digital enterprise. So he's well into digital technologies. He's an active participant in the Open Group and is co-chair of the MSA work group with SOM. So I'm Harding. I'm the Director of Interoperability at the Open Group, and it will be my pleasure to moderate the panel sessions. So without further ado, I'd like to move on and ask John to kick the overview that we're giving of microservices architecture, after which we will have the panel discussion.
Good morning, everybody. And just as a note, many slides come from work that's going on in the current microservices architecture working group, based on the discussions that we've had in there. Some history. SOA allows you to control distributed computing costs by leveraging the infrastructure that's built for the web. It allowed companies to increase their agility by allowing more responsiveness to change. It's built on top of XML and HTTP and other technologies. Alternatives to services-oriented architectures were Quora, DCOM. These were complex and expensive solutions. Web services were considered to be significantly easier to implement and less expensive since they were built on top of lightweight infrastructure that companies were already putting in place in order to participate in the World Wide Web. As companies started to use SOA, the requirements that they had for types of things they wanted to do grew, and they added to the complexity of SOA as they added more components to the architectures. And today's services architecture is perceived as complex and expensive. Peter, would you like to add comments?
Yeah, and I think, SOA was, a logical response to the fact that you had all these rapidly developing, web technologies, as John has already mentioned, like XML and HTTP, to try and get away from, the very large monolithic enterprise application developments and the very long development and deployment cycles that those result in. But part of the perception, and some of this is only perception, some of it is reality, based on the history of SOA as implemented, is that what you've ended up doing is trading the complications of large monolithic applications, and you simply replace those by the complications of running everything through an enterprise service bus.
Thank you. Sam, did you want to add? On mute. Base, is there anything you wanted to add?
Yes, thank you. I think that was a great point made on the complexity by you and Peter, but I think another thing that was driving this historically was this whole perception of disconnect between business and the IT because of the kind of technical debt or the bloat that the existing architecture paradigms had now inherited or had accumulated over time. There was more of technical talk and not enough business connect with what was happening. And services is being an initiative bottom up to try and bring much better to actually align and be more in tune with what the business needs are, right?
Yeah, sorry, this is Tom here. I was on mute. One thing that I also wanted to add here is the ESB. The enterprise service bus is often talked with the SOA landscape, the service-oriented architecture landscape, and when the expense of implementing a large ESB is to be, a complex and expensive, and factors that people wanted to move away from SOA, if you will.
So, if we can move to the next slide.
Okay.
So microservices architectures were developed as a pushback against the complexity of SOA. They've emerged from the lessons that we've learned in real-world use. The idea is to focus on a single business function and create services that implement the operations required by that function. So the intent here is to make something that's simpler, that's more focused, easy to implement, and easier to deploy than what's been considered over the last evolved over the last couple of decades is services. Peter?
Yeah, so we had a long series of discussions leading up to this, and one of the things we really ended up concentrating on a lot during the discussion was really the importance of the concept of the single business function. That the emphasis on meeting a single atomic business need, poorly decomposed, that's really the driving force behind the definition of a microservice architecture, and we'll see a little bit more of that as we get a little further into this.
Tom?
Yeah, I think that's well covered. We would see statistics of what really makes up as in the subsequent slide that would eliminate what microservices is beyond this definition.
Nice.
This time, apologies. Saying, I think one aspect that's relevant to that microservices bring is the fact that it is it's a bottom-up paradigm. It's been initiated and being led by the developers and their understanding of how applications should be developed and how applications can be developed more in better response to the business needs. Developer-led bottom-up initiative, unlike a lot of other architecture initiatives. Right.
Next slide, please. So the working group is agreed that the definition for microservices architecture is it is a style of architecture that designs and creates systems through the use of small, independent, and self-contained services aligned closely with business activities. Microservices architecture is a subset of a full services-oriented architecture with the added constraints of service independence. Peter?
Yeah, I think impossible to stress this too strongly. I mean, we had, as I said, a long series of discussions. We polled subject matter experts across a wide range of enterprises, and really the number one defining characteristic of an MSA, it's really the thing that distinguishes it from others. So, because it is a subset of that, is the independence of services, and will the importance of that as we continue going into this.
MSA, in a sense, as here, is a single-purpose, self-contained, independent services which are very highly decoupled and operate to provide a high resilient solution. And MSA, in many aspects, is like SOA, but with more prescriptive and with added constraints.
Yes.
This is well covered by three of you. I think we have the ends of MSA over here, very well defined, and in fact later found a framework of how one MSA effectively versus a non-MSA, right, if I might call it that. But the idea of it being very similar but with added constraints and governed by principles is what makes it an MSA, right?
Next slide. So an MSA is sort of independent of other services. So a service within an MSA is independent of other services within an MSA. It uses this independence and the parallelism that it permits to achieve architectural resilience and scalability. So one of the concepts in MSA is when services are deployed, each instance of deployment is independent of the other deployment instances. This allows you to deploy a number of parallel instances. If an instance goes down, a new instance can be brought up to replace it, but the other instances can handle the load. The load can be distributed across the multiple instances. It's partly of how it gets its resilience. It's also how it gets its scalability. You can dynamically add and remove instances as needed in order to scale the volume of service requests that you're getting. And MSA is constrained, focusing on single responsibility per service. So we're not looking for one service that does all things. We're looking at a service that does one thing and does it well. It is not comprised of other services. A service in an MSA is not comprised of other services. due to the independence requirement. So services have to be standalone within MSA. These are some of the constraints of the architecture, but it's what also gives it its strengths. So
Yeah, and we did discuss this at great length during the white paper development. Find what the key characters really were. And it's really, I think, important to make the distinction. It's the independence of the services. It's really the key characteristics of an MSA, and that's what makes the architectural resiliency and scalability possible. Obviously, it does require you to be able to decompose your system requirements down to get to pretty atomic business capabilities, and it's atomic business capability which is the one thing a service is dedicated to fulfilling in a microservice architecture. And it's like, just do your job and do it well.
Yeah. I would like to add that the resiliency factor that we talked about is really achieved by the platform. For instance, let's say there is a service that's up and running and it gets down for whatever reason. The platform is intelligent enough to spawn additional services in place of that service that went down to cater for the upcoming intakes of requests. So that's kind of resiliency achieved with parallelism. The other aspect also I would like to add is the orchestration and choreography models that a service composition typically talked about in a service-oriented architecture, and MSA leans more towards the choreography model, where it is an undirected, exchange between independent services.
Yes, and that was very well captured. I think what is probably relevant but not exactly evident over there is that say composed of services, as we said, and the services are self-contained. So effectively, that is what allows for the independence between them, as well as the resiliency and so forth. That is the result of that, right? So containment is a key function of an MSA service.
And I'd like to add on to what Sam said. The platform allows you to have that elasticity, but the independence of the services allow those multiple instances to coexist without conflicting with each other. Let's go ahead and go to the next slide. So there are three core principles that the working group has agreed on for microservices architecture. One is independence. A microservice is independent of other services and instances of the microservice. Responsibility, a microservice is focused on doing one thing and doing it well. I didn't have enough room to put well here, but it's one thing and doing it well. And self-containment. Everything the microservice requires is packaged with the service deployment unit. It's packaged as a individual unit and it can be deployed and operated as different instantiations of the deployment unit. So, Peter?
To elaborate a little bit further, last bullet, right? It's a self-containment principle is what allows the individual services to be developed, deployed, and also replaced or upgrade in a manner that's totally transparent to the user, right? And because the code is changed in relatively small increments, developing, testing, and deployment or redeployment can happen in short order, which is, one of the other advantages that a microservice architecture brings to the table.
Yeah, I would add to what Peter and John had said is that this architecture, if an architecture review is conducted and someone comes and says, I'm following an MSA, I expect these principles to be in play, right? It should be independence, single responsible, and self-containment should all be there in a pure MSA parlance. Doesn't mean that we can't violate for any business reasons that you have, then, calling it a pure MSA may not be the right way to do it. An MSA influenced architecture would be a better way. In an MSA puristic sense, we are expecting all these three principles to be in play. And the white paper that Peter was mentioning earlier, we have elaborated these principles in terms of a statement, rationale, and implications following the TOGAF methodology.
Yes, and I was pleased and thrilled that you mentioned the fact that single responsibility is there. It's also doing things well, right? I think that's the essence of a microservice. The fact that it is atomic in nature, but and then all the other factors. But what's critical is that it's able to perform that function extremely well, and it's from the business, from an atomic business function perspective, as Peter had mentioned earlier. So a business requires a certain function. Your service is able to cater to it perfectly without with least resistance to it, right?
I wanted to make an additional comment. That is, within the TOGAF model, you define principles, and principles are your guidance for your architecture. So all of the principles as guidelines. And if you have to violate a principle, it doesn't mean you can't violate a principle, but you need to have the proper governance. You need to have, in rehearsal, I talked about using go-tos in C. If a programmer is working for me and they put a go-to in a piece of C or C++ code, they have to or Java code for that matter, they have to completely document the validity of that go-to and why there was no other way of solving that problem. That type of governance is required if you're going to violate a principle. You need to understand why you're going to violate that principle and implement the appropriate governance for that. So with that comment, I'm ready to move on to the next slide. Thank you, everybody. This is a good discussion. So it's best to use a microservice when you're looking for rapid development because microservices tend to be very small. They lend themselves well for rapid development. When you're doing a new development, because services independence requirement makes it hard to make it dependent on existing legacy back-end systems. When there's no dependence on existing infrastructure, so if you've already got a services-oriented infrastructure, you may not get all of the value out of a microservices architecture if you've got a team that's already experienced and you've got the existing infrastructure in place. And if you can support multiple parallel development teams. One of the advantages of microservices, because they are single business function focused, you can do parallel development, parallel deployment. Deployment of one microservice does have dependency on deployment of other microservices, and if you can support multiple parallel teams, then it's a good opportunity to use the microservices architecture. Peter?
Yes, these are not hard and fast rules, but they're really guidelines for the best cases to take advantage of what MSAs can offer. If there's too many cross dependencies in an application, so you can't decompose it in pieces small enough to be implemented as independent services, uncovering an MSA is not necessarily a good fit for that problem. Or if you don't have luxury of fielding multiple development teams in parallel, and those services are going to have to be developed by a single team or a handful of teams in a serial fashion, it's going to take difficult to achieve the rapid development and deployment that MSA offers.
I would add to what Peter and John had mentioned. The development really leads to the business agility. That's the key, right? So achieving the business agility in terms of decomposing the services at the right granularity level so that the changes are encapsulated in such a way that when business change happens, the service that needs to change only changes, leaving out all other services intact, right? So that's where the business agility is a key factor that helps with or that is a result of the rapid development and new development options. SOA world, SOA was a decade old, and it born before DevOps was fully evangelized and fully popular. The development and operation teams coming together, operating as a single team in a DevOps concept, as well as the advent of cloud. Cloud is in the infrastructure as a service, all the way to platform and software as a service models, which we currently see, and that's kind of the evolution. What we see that microservices has taken place with DevOps and cloud infrastructures in place.
Just to add to that, I'd like to emphasize on the point that was made earlier by all three of you, is that microservices are enablers to lots of things, and this is just So this is by no means a comprehensive list of best of use, but a guidance sort of. And it's not silver bullet as such. It not solve all your problems. So it will be one of the things in your portfolio of tools in enterprise architecture to use to solve specific problems that have been identified, things where you can easily decompose, where you need greater agility, where you need greater business alignment, and where you don't already have a large infrastructure investment to build on. So you can do this much more efficiently and at a much better cost point, right?
And next slide, please. So, and some other notes is that microservices support technologies like Node.js. If you're not familiar with it, Node.js is a server written in JavaScript for hosting web pages, web applications, purely done in JavaScript. This is a good potential platform, one of the many, a good potential platform for web services. Companies have been very excited about what they can do with Node.js, and it's a good candidate for using as a microservice platform. They're used by companies like Netflix. And we talked about the independence. If you think of a layered architecture, you can have that service architecture layer within your larger enterprise architecture. And one of the layers above your MSA, either at a higher services layer or in an application layer. And this is very common to see as microservices architectures being orchestrated at the application layers. So within the microservices architecture itself, there's no way, because of the independence constraint, to do orchestration, but can do orchestration at layers that are above the microservices architecture layer. So, Peter?
One thing too is that, as John talked about technologies, as your architecture and applications develop, and you've got multiple independent teams, it really gives you the option of, and the flexibility of always trying to choose the best technology to solve the particular problem most effectively. Obviously, within reason. And decentralized governance is also, goes along with developing an MSA. And, that does not mean suddenly tossing out all your coding standards or turning your development teams into an uncontrolled free-for-all, by any stretch of the imagination. But it does give you more flexibility to allow your application and your coding to evolve as the new technologies permit.
Yeah, and back to John's comment about the application layer, if you will. Microservices, I can kind of break it down into three main components. If you are, looking at microservices itself, microservice architecture platform, which is underlying these, and on top of it is a framework, a microservice architecture framework that will help the platform to the microservice instances or the business function that you would encapsulate as a microservice that is deployed on top of the platform via the framework, right? And there are several open source frameworks that are very popular and upcoming with the microservices, advent of microservices itself. Docker being something that is majorly upcoming. There's been a huge adoption over the last year that, people who are adopting microservices are using Docker containers to club together their configurations together in one single instance that's deployable and replaceable. Similar tools exist in the container space, but also in a platform as a holistic. We have Source, Marathon, and a lot of software load balancers like JProxy, whatnot. So thinking about building that microservice architecture platform either in the cloud or on-premise, there are many open source options out there.
I think what was evident in that whole discussion to everybody is the fact that it's, even though this is cutting edge and a new paradigm, there's a level of maturity in the industry now around the support that's available for developing, deploying microservices, or for the entire, DevOps cycle for microservices, both as in platforms, as in frameworks, as in technology, as in architecture. So, end of the day, the biggest concerns when adopting something very new is the risk that's inherited, right, or the risk set. And effectively, having reached a certain level of maturity now, microservice is ready for mainstream. It's already been deployed by some very large organizations, as mentioned over here, very successfully. So there are good use cases and good references to look at when doing microservices. So because of where the industry has reached now in terms of enablers for microservices, I think it's in time. It's ready to be adopted for mainstream.
Sure, Chris, but I think we might have skipped a slide. Can we go back to slide 7?
Yeah, you did.
Oh, apologies.
I've been looking for that and been wondering where it was. Okay. So one or another, we skipped this particular slide, which is the characteristics of a microservice. And so I'll put some of the later slides in context. A microservice is independent of other external sources. We've clearly stated that. We've also talked about it supports elastic deployment. Elasticity gives you resilience against a failure and makes your services dynamically scalable. It's parallel development and operations. So we've talked about parallel development and operations, but it allows for independence of development teams. So if you have a project that involves 5 different microservice areas, and right now I'm working on a project that has about 8 different microservices that are part of the project. Those services can be developed by a team completely independently of the other teams. So at that service layer, your teams have complete independence and independence of deployment and of governance. So it allows teams to move a lot faster because the coordination that's normally required between teams developing large, complex projects is required because the microservices are independent of each other. This makes microservices trend towards small modules that are supported by small teams and have short, fast, and less costly development cycles per project on a per project, per service basis. So, Peter, I'm going to let you pick up from here.
Yeah, and I think if you really look at these last 2 bullets, the parallel development and the small modules, I mean, so these are clearly not hard and fast requirements, but I think it's one of the reasons why seeing MSA become popular at the same time on the rise of approaches such as DevOps and also agile development approaches, and whether it's Scrum methodology or something else. So those are all about getting code, integrated testing, and therefore, wrung out and debugged as quickly as possible, which is what allows you to make rapid deployment of high-quality code.
And add that, not any single characteristics is more important, but a combination of all these characteristics is what really makes MSA distinct from any other architectural style.
I found that very funny because true MSA, so is this deck, right? Each slide seems to be self-contained and independent, and we can choreograph them in any order, right? Exactly. But this is like, I'm glad you brought this back, John, this slide, because this has been the sense of the work that's been done in a work group, an open group work group on microservice architecture. A whole deep discussions on the characteristics, what was perceived in industry, what was perceived by the participants, and what then we distilled down to what was really relevant and specific to the definition of microservices, right? So these we can have a deep discussion on. I just want to pick one theme out of this, which is around the small modules and small teams. What that enables is this whole polyglot paradigm, right? And in today's industry, where there's so much different development and resources and so forth required, one of the constraints is always getting the right team and right skill sets and right resources to execute on a project. And if you are constrained by a certain by a limitation to a particular platform through either because of standardization and so forth, then that becomes a risk if you're going to be able to find that at time T2 or in 5 years down the line. This mitigates that because you can develop with whatever is the most optimal available resources and skill sets time and develop the particular function or application that you need and get moving. It could be completely different tomorrow, right? So it goes back to being able to meet the business needs in a optimal and least risk manner, right?
So, Chris, if you can now go ahead and move us back to the end of the deck.
Okay. Also?
So we've covered this one. I think we're ready to go to the next one.
We covered, okay.
Yeah, which is the question and answer period.
Right, so thanks to John and the other panelists presentation. There've been a very large number of interesting questions. I think some of them may have been addressed as we go forward. Sorry, as the panel presentation went forward. Can I just pick on one particular aspect which has been asked by a couple of people relating to the fact that you have a large number of small teams, maybe 1,000 programmers in a large enterprise working on a microservices architecture. How do you, doesn't this lead to inefficiencies like data being copied more than it needs to be because of the independence of the microservices? Doesn't it lead to duplication with the same functionality being implemented in different microservices? How do you control that?
I think that's an excellent question. A lot of that experience is if your microservice is well focused. So I work very much in the hotel industry, the hospitality industry, and if we take, for example, the idea of a guest profile, the idea of a hotel inventory availability system, and a hotel reservation system, each of those could be separate microservices. When I go and I retrieve a guest profile, it really has no relationship to the individual hotels in my system. There may be a relationship to the reservations. I can manage that relationship by having my reservation system have that link back to the guest profile, and then I pull up the reservations for that guest based on that link, or I can have links in the guest profile to the individual reservations. Then I don't have to duplicate my reservations. I don't have to duplicate my guest profile information. All I have to do is provide a link, and since I'm using a RESTful model here, that link ends up being the URL for the related record. I have to provide a link in that data object. I can't create a reservation without assigning a person to that reservation and assigning a hotel to that reservation. So I have to, the application layer, pull up those two resources through the microservices, where I can create an instance of the resource, the reservation resource, within that context.
So that's a good point there, John. And I think it's a good question because that's one of the things being asked in the industry is the whole idea around does microservices lead to chaos, right? And we have had this discussion in the work group as well around the whole idea around towards is a decentralized or a federated governance model that is more conducive to microservices. And so, I mean, I think we're not saying we're moving away from scribing and saying everything should be a single point of truth, the data, nothing should be duplicated, and there should be complete reuse and so forth. We are dealing now with business and what the business function need is, and how best to serve that. So there might be some duplication. There might be some, it may not be the biggest driver in this thing because it is now what the business needs and how best to achieve that. But I think the efficiencies are still much better because each of those functions are developed much more efficiently and are catering. As John pointed out, you will, if you align with the business function and the needs of that, you automatically will end up with specific information and data needs that cater to those without having to duplicate them, right?
I think that's well said, Oves. I would also add that this proliferation is being often considered as a very bad thing with respect to the service road architecture. Don't take me wrong, service proliferation, when it gets to the nano services, which is an high pattern level, that becomes really uncontrollable. But with sophisticated service registry and repository tools, wherein when a service gets developed and deployed, it's automatically discovered and exposed to other service builders that this service exists and this is the function it's really performing. If you want, you can fork it and have several instances deployed in your environment or reuse a service with multiple instances is a suggestion that can be made, right? So that's a way of looking at it with respect to, the federated governance that, Oves was mentioning, and empowering the teams with that choices of implementation and, how can they reuse a service that might be available in another area.
And the thing I'd like to go ahead and point out here is that microservices are good for solving certain classes of architectural problems. Not the end-all architectural solution. It is one of the tools in your toolbox. Today, microservices architecture is an ideal architecture for certain types of applications and certain types of environments, but I would rarely consider it an adequate enterprise class architecture. And so, be aware of that, is that it's a tool, and those places where it works well, it works very, very well. The places where it's not going to be the best tool for your particular problem, your particular solution.
Okay, that's a valid point to make. No single architecture is likely to be perfect for all problems. Another topic which came up quite often in questions in the chat relating to composition and orchestration. And I think to some extent that got answered in the presentation with the point about common orchestration being addressed at higher layers above microservices. But the further questions coming in asking, doesn't that really mean that you're shifting the problem upwards to achieve simplicity in the microservices, if you like, at the cost of extra cost and difficulty and complexity at the layers where the orchestration and composition is taking place?
Another very good question. Some of the answer is complicated. If you're, for example, creating a mobile application, and I'll go back to my hotel industry example again. If I'm creating a mobile application for creating reservations or even a web application, most of the kinds of things I need to coordinate are really built around that reservation. I can go ahead and search for a hotel. I can find out if a hotel is available. I can do all that with the hotel services. Anything I want to find out about my previous relationship with the hotel as a guest, I can out through my guest profile and the services around that. Create a reservation, though, as I said before, I have to take guest profile to a hotel and to that availability record within that hotel. In order to do that, I'm normally, in my normal process of doing business, going to look for a hotel, going to identify myself as a customer, and then I'm going to create my reservation. I could do that at a services layer, but this is fairly simple. I'm doing this all at the applications layer in a lot of hotel companies. That's exactly where they do it. They do it right at the applications layer. And now I have no orchestration layer other than my application layer. It depends on the nature and the complexity of the problem. There are certain things that I like to do for orchestration when I'm creating a service. Is I'll typically have a service go through validation phase, and authorization phase, and authentication phase. I'm not necessarily giving it in the same order. I like to use either chain of command or some lightweight orchestration to do that. And then finally, in a microservices architecture, you remember that everything is contained within a microservice. So if I'm going to use Camel in order to do that, Camel is a tool that a number of projects that I've worked on have used internally. I use Camel as part of my deployment for the service. So I'll do that orchestration where I validate and authenticate the service, and I try to do it without having to talk to anything else. I try internally, so I use tokens that are self-authenticating, validating, that type of thing. I do that in that same stack for the platform that's delivering the service. So I don't have Camel that orchestrates across multiple services with different purposes and different resources. Camel's just used for orchestrating actually within a service to make it easier and easier to maintain and accommodate new needs. Hopefully that clarifies that.
Yeah, John, I just wanted to pitch in here and quickly add a couple of points there, right? So when it comes to microservice, it's actually the other way around of complexity. We talk about smart endpoints and dump pipes, meaning like the middleware channel that really communicates message doesn't have a clue of any sophisticated logic being in, like rule-based routing. That's not the way that microservices is leaning towards. More often event-driven architectural style, right? So the endpoints publishes events, and the listeners who listen to those events interpret and act accordingly, right? So interpreting services, the microservices that interprets it, knows what to do with that message and proceeds accordingly. Make sure, I kind of clarified when I said orchestration and choreography in the composition context. Orchestration is dictated, meaning like there is a single service which knows which order to execute, the service, and if that service fails, and it has a dependency on other services which doesn't really fit the microservices architect build. But choreography is a much more independent model where a service will publish the event and it doesn't really care about or doesn't know about existence of other microservices in the ecosystem. So the other microservices picks up the event and acts accordingly. So RabbitMQ, ActiveMQ are some of the wares I have used, but reliance much on what functionality they operate internally.
Yeah, I think that's a great point there you made on, because really, if you look at it from a business process perspective, a process is a set of activities that are then choreographed together, right? And either being done by a person or an application. So following the paradigm, instead of moving all that logic and create a very bloated technical stack in the middle that has to do all the orchestration, it is more conducive to have each of those activities as a microservice. May not necessarily be the one-to-one, but those activities effectively being involving as the atomic business functions as the microservices, and then just orchestrate them or choreograph them in the application or the layer outside of it as a business process was execute, right? Whether it be through events or through user interaction. But it's much better with a business process paradigm or the way the business process typically is laid out itself, right?
Thank you. Do you want to add anything before we move on to another question?
No, I think everyone's more than covered that, and we should just try and squeeze in as many questions as possible.
Thank you. Go ahead, Chris.
Okay, let's move to a slightly different area then. there's been a number of questions relating to the relationship between microservices architecture and REST. Is a microservice basically a REST service? Should microservices communicate with each other asynchronously through a messaging system or through REST calls? So, I guess sort of what does a microservice actually look like? How is it invoked, and how do they talk to each other?
Okay, so let me like the first one is the microservices architecture does not have to be a RESTful-based architecture. However, many instances of microservices architecture that I've seen implemented are based on RESTful models. When you look at a SOAP model, it has a lot of power in it, and it's a great architecture, but it is a heavy architecture, and so many people implementing microservices architecture are going to go to lighter weight architectures, and REST is a potential candidate for that. Hope that answers the question. And when I say REST, I don't mean JSON. I mean actual RESTful, where it could be JSON or XML or whatever payload package is appropriate for your service. But the other piece of that is that how do services talk to each other? This is a microservices architecture. Services don't talk to each other. They're independent. They don't have a requirement to talk to each other. And so we've got some of the asynchronous means of communication. Again, if that creates a dependency between two services, so one service can't accomplish its job without talking to the other service, you're probably leaving the realm of the microservices architecture, and you want to move up. You want to move that orchestration or that dependency up a layer or so in your architecture. So, anybody else add?
Yeah, REST, as John rightly pointed out, is as Roy Fielding defined, it has constraints and it has some principles adhering to it, right? It's in no way it's upping to microservices architecture or it's in favor of that, right? So you could build a REST-style microservices architecture, or you could unREST and just use JSON or HTTP as your communication protocol and format, and still have a lightweight mechanism of having the messages received and published in an asynchronous way.
That was a great clarification. Thank you.
Just to emphasize and expand a little bit on one of the things that John said, it's about independence, and I've seen a number of questions scroll by asking about, well, how do you know, what level do you have to decompose in an MSA? And it's really need to decompose to the point where you can actually have services that are independent, and if you got a business function that's still dependent on something else, you're either not far enough down yet, or an MSA isn't necessarily the right place, the right architectural solution to that problem.
An answer, and let me go. Your microservice may be a little larger to prevent dependencies. For example, I might have a hotel inventory system that's burned off, say hotel marketing, information delivery, that kind of thing. I might have room descriptions and room type descriptions and that type of thing in my hotel inventory because I need all of those operations working together in concert in order to deliver the information I need about hotel inventory. So I make a larger service area in order to meet that need, in order to maintain that as a microservice. So it's not just a matter of, hey, I need room types in order to maintain inventory. I need individual rooms to maintain inventory. I need the descriptive information around those room types as well, and I'll go to that service area to get those descriptions. I'll have to break it up into another service area where I'm going to end up creating a dependency.
Yeah, you said that right. And repeat that the decomposition is probably more of an art than a science, but it really is linked to your business process. Point, you decompose your process down to a level where you end up with each activity being a single activity. There's no dependency on the activities. It doesn't have multiple activities grouped into one and so forth. So once you come down to what is a single single activity for your business, that level of decomposition to stop at. Now, that single activity for your business may not necessarily be a single activity for another business or a similar business. They may decompose it down. They may be two activities for them. So it's a balancing act to figure out where to for what makes the right level of atomic business activity for your business, right?
Towards the two end of the spectrum, what we call it as the monoliths, being the large big mud, right? And the other end of the spectrum is the nano services, which is an anti-pattern of totally overly decomposing the service beyond what the business needs. And between the monolith and the nano services is a thin line where microservices is the right place, right? So that's kind of wanted to add more resources.
That's a great point, Sam. I think that's and I think you did a pictorial in the paper for describing that as well, right? Yes.
Yeah, I agree.
So that actually answered another set of questions that were in there on the definition of services. So, and I do apologize to everyone who's asking these questions. There are just too many to put all of them to the panelists. I'm trying to abstract and combine threads of question to this point. If we can finally briefly cover another question, which is, okay, so assuming you've decided that a microservices architecture is what you want, and you have traditional SOA at the moment, how do you get from where you are to where you want to be?
My recommendation is you use your microservices architecture for a greenfield application. You use your SOA, your SOA on top of that microservices architecture for binding those independent services together in those situations where you need to. In those situations where you don't need to, there's no need to integrate the two. The beauty of the microservices architecture, it can stand alone. You do your integration where you need to do it, the applications and various consumers of the services.
What to remember, and maybe relevant to that question, is the fact that there is a paradigm shift over here, right? I mean, we talk about paradigm shifts in terms of SOA and so forth. Here, there's also a paradigm shift both on the business and IT side of the organization, because to act and work with the microservices way, you have to get rid of a lot of the other things you might have learned in the past, right? I mean, agreed, microservices is just one of the tools in your portfolio, but if you're doing microservices, you work very differently than you would do if you were doing, for example, a standard SOA. You had a large infrastructure and you're developing services and exposing them to businesses. Here, working with the business actually owns that application. The model is different. The governance model is different because it's more federated, and the whole DevOps paradigm is more enabled than it would be in many other cases, right?
I would also add to what Voice is kind of saying is that there needs to be a roadmap that would have to put forth in terms of what steps you wanted to take in action. That one suggestion could be that you can start exploring microservices within your existing infrastructure, building a platform framework, and creating some small microservices that can coexist in your infrastructure, and then gradually get to the next level for DevOps, right? Establishing the DevOps, forming small teams, and then talk about the decentralized data management models and how you really get towards rated governance, point-to-point integrations, and monitoring detection techniques, all those things. So there needs to be a roadmap for you to get from point A to point B, and this is very relevant for moving forward to microservices as well.
Another point to that is a great point, Sam, and something that talked about is a single ownership, and we haven't touched upon that in detail over here, but another time. But the idea of single ownership of that application end to end, from line development all the way up to retirement, operations and retirement, is a single team ownership, right? And that's a powerful concept. We can explore that maybe another time.
Yeah, that's it. So that's again cultural aspects also to be taken into fact. Should work with your organization culture in terms of bringing in the single ownership and DevOps concepts. Well said, always.
And one thing, just logistically, since we are sort of out of time here, I noticed a number of questions that ask A, about the availability of the webcast as a recording later on, and B, a number of questions about the white paper that we're working on.
And those are good things to end on. Do you want a final word on the question of migration to microservices, Peter, before we move to the publication of the slides and of the white paper?
Somanovic answered that very well, and I'm sort of for another meeting myself. So
okay, that's so. Thank you everyone for participating, and to our panelists for trying to answer some least of the wealth of questions that were asked. The slides will be made available on the webinar webpage. So if you go to the Open Group website, you find the developments in SOA series of webinars of which this is part. You find the page for this webinar. The slides will be posted there, and I think. Simon, I'm right in saying that a mail will be sent to everyone attending this webinar as a wrap-up, just to point logistical details such as this.
Yeah, correct.
So that's good. The white paper that is being produced by the team will be published in the Open Group publications catalogue, and again, if you go to the Open Group page and look under publications, you'll find a link to that publications catalogue. As to when it will appear, that's really a matter of when the team has finished it. We are hoping that it will be within a few weeks from now. There will be time, obviously, to review it before it can be published. And if this team starts trying to answer all the questions that have come up in this webinar, it may take a little longer to finish the white paper. I don't know how they're thinking about that. But
yeah, Chris, I know we talked about publishing that preliminary paper. Is that going to be published?
So we will go through the Open Group process, and obviously we can't guarantee publication of anything, but we're aiming to publish within a few weeks. So with that, I'd like to thank everyone for participating again, and particularly to thank Peter, Som, and John for the presentation and for answering the questions. Thank you all.
Thank you.